Intercepts of a line. So we've talked about intercepts before, x and y intercepts before, but let's talk about them as they relate to a line. So for this problem that we see, find the slope and x and y intercepts of the line, then sketch the graph. And we have our equation in what is kind of general form of a line. I'm not going to talk about general form of a line, but sometimes we see lines that are in this form where you have x and y on one side and a constant on another. And I like to think of this more as intercept form because it's actually a great way for us to find the x and y intercepts. So as a reminder, your x-intercept, that's where your y value is 0. An x-intercept is where you cross the x-axis. If you cross the x-axis, then your y value is 0, right? Right here at -4, if I had a point right here, I would be crossing the x-axis and the y value would be 0 there. So this is where y is 0. So in order to find the x-intercept, we would plug in 0 for y. But plugging in 0 for y is really the same thing as just kind of ignoring y, right? Just kind of like ignore y. Ignore. So if you have x plus y equals -3, and we're trying to solve for the x-intercept, which is the same thing as plugging in 0 for y, ignore, 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 you're left with x equals -3. That's the x-intercept. So we cross the x-axis at -3. For the y-intercept, we have a y-intercept when we hit the y-axis. And if we hit the y-axis, our x value is 0. So this is where x is equal to 0. In the case that we have, I'm going to call it intercept form. If we have intercept form of a line, it's really easy for us to just plug in x equals 0 by just ignoring the x. Ignore x. And if you do that, if you just ignore x, you're left with y equals -3. So the y-intercept is at -3. We can plot a line. I didn't do a great job of plotting this line. Doo, doo, doo. You know, do your best. Good enough there. I can draw this line, and bam, we've sketched it. To find the slope, it's actually pretty easy to do because you now have really nicely plotted points here. So starting with my leftmost point, I need to go down 3 units and to the right 3 units. So my rise over run, I'm going down 3 to the right 3, so -3 over 3, which is -1. What's great is we could also write the equation of the line in mx plus b, y equals mx plus b form really easily. We know our slope, which is m, our y-intercept, which is b. So if we wanted to write it in y equals mx plus b form, slope-intercept form, this would be y equals -x minus 3. So this -3 is from the y-intercept. And that negative up front is because of the -1 slope. So let's try it again. The x-intercept, again, we are ignoring y. So this works, again, when you have it in this form where you have x and y on one side and the constant on the other. So if we have 6x minus 3y equals 18, and I'm trying to find the x-intercept, really I'm plugging in 0 for y, but because that just cancels that out, we can just ignore it. So 6x is equal to 18. Divide by 6 on both sides. We get x equal to 3. So our x-intercept is 3. For our y-intercept, we ignore x. So we have 6x minus 3y equal to 18. We are ignoring x, so I'm just going to scribble that out, making sure to keep the negative in there. So I have -3y equals 18. Dividing both sides by -3 to solve for y. We get y equals -6. What did I type? What did I write up here? I wrote x. Should have been a 3 and a -6. So the y-intercept is -6. And then I just draw a line through these points, and maybe I can make this line better by drawing it that way. Good enough. Finding my slope, I'm starting with my leftmost point. Did I use green before? Yeah, I'll use green again. I'm starting with my leftmost point right here. I need to go up 6 units. So this is +6 because I'm going up. And then to the right 3 units. So my slope, rise over run, is 6 over 3. That simplifies down to 2. What colors did I use? Y-intercept was blue. All right, so the y-intercept right here. And the x-intercept is right here. And if I wanted to write my equation in y equals mx plus b form without rearranging this, because I could just rearrange it, but it's a lot more difficult that way. I have my slope, I have my y-intercept. My equation is y equals, slope is 2, 2x minus 6. And that would be the same thing you would get as if you rearranged this equation, right? You could like do -6x minus 6x. Then you get -3y is equal to -6x plus 18. And then you would divide all of this by -3. It's a huge bummer. It's a little bit of extra work. We get y equals 2x minus 6. Same thing. Same thing. So let's just do more of it. Again, I'm not going to write as much this time. For my x-intercept, I'm ignoring y. So I'm just ignoring this y part here. Now is a great time to practice, by the way. You can pause me and practice right now. So my x-intercept, -2x is equal to 6. Divide both sides by -2, and you get x equal to -3. X-intercept is -3. For the y-intercept, I am ignoring x. So I have 3y is equal to 6. Y is equal to 2. Boom, line. for my slope to get from this left point to the right point, up 2 to the right 3. My slope is 2/3, rise over run. My equation in y equals mx plus b form, by equals 2/3 x plus 2. Down here, for the x-intercept, I am ignoring y. So 3x equals -12. Divide by 3, x equals -4. My x-intercept is -4. For the y-intercept, I am ignoring x. So we have -4y equals -12. Y equals 3. Plotted my line, choosing my left point. To get to my left, from my left point to my right point, we have to go up 3 units. We have to go to the right 4 units. So rise over run, 3 over 4. Positive because I'm going up to get to the next point. In y equals mx plus b form, this is y equals 3/4 x plus 3. So that's all I have to say about x and y intercepts and lines. It's really convenient when you see your line given like this to use these x and y intercepts. And we really like to think about the different tricks we have up our sleeve for the different forms of these lines, because you wouldn't want to use the x and y intercepts if you had a line that was already in y equals mx plus b form. You wouldn't want to graph it using those x and y intercepts because it's way easier to just use that y-intercept and that slope. So that's all I have to say on this one. That is x and y-intercepts of a line.